Hi students. So today we are solving the problem of Modi method. In the last lecture also we have solved the Modi method. Now this is a problem we have solved in a lecture number 6, that is solved by the northwest corner rule or northwest corner method. Today we will solve this problem with the Modi method. So I will provide the link of lecture number 6 in the description. So this is a problem where there are the factories. So factories located at Ahmedabad, Ernakulam and Kanpur, where production is 30, 40 and 50, and same time demand is from the Bombay, Kolkata, Delhi and Madras. So demand is 35, 28, 32 and 25. So what is the problem? So the transportation cost from each factory to each distribution center is given here. So this is a that is a cost matrix we can say, and obtain initial basic feasible solution using a northwest corner rule. Previously we have solved in the lecture number 6, we have solved by the northwest corner method, and after that it is asked using suitable method carry out one iteration to obtain improved solution. So here we have to use the modified distribution method or Modi method to solve the problem further. So first I will once again revise the problem. So here Ahmedabad is a factory where production is a 30, then in Ernakulam there is a 40, and in the Kanpur there is a production is a 50, as well as at the same time demand from the Bombay is 35, then Kolkata is 28 and Delhi 32 and Madras 25. So by using the northwest corner rule, what is the initial basic feasible solution? That is solved in lecture number 6. I will provide the link of lecture number 6. You can go through that. So this is the answer, initial basic feasible solution by the northwest corner rule. So here we have to provide the location at the northwest corner, and initial basic feasible solution is 1076, and these are the allocations for the this problem. So 6 products are transferred, or 30 products are transferred with the cost of 6 rupees, 5 products with the cost of 5 rupees, 28 products with the cost of 11 rupees. So this is a answer by the northwest corner rule or northwest corner method. Now obtain initial basic feasible solution by modified distribution method or Modi method. So for that, first condition is check for a degeneracy. So I will write here, first condition, check for degeneracy. So what is degeneracy? Degeneracy is, there is a formula, m plus n minus 1 is equal to number of allocations or not. So in this problem we know the m is a number of rows. So if we check the number of rows, so there are 3 rows and there are 4 columns. So 3 plus 4 minus 1, that means 7 minus 1, that is a 6, is equal to number of allocation. If we check the number of allocation, so this is 1 2 3 4 5 and 6. So 6 allocations are there, and m plus n minus 1 is also equal to 6. So we can solve, when this condition is satisfied, then we can solve the problem by the Modi method, because this is not a degeneracy type problem. So we will go to Modi method. So for that, this is our answer matrix. Here I will write for a row, that is u1, that is a row number 1, u2 row number 2, u3 that is a row number 3. Similarly v1, that is column number 1, v2 column number 2, v3 column number 3, and v4 that is a column number 4. So first we are solving for a occupied cell, like in previous lecture I have mentioned in detail. So for occupied cell, relation is ui plus vj is equal to Cij. So U, that is for row, V for column, and C, that is nothing but the cost. So 6 5 8 5. So here 6 5 8 5, these are the cost, and U, that is for row, V, that is for the column. So first we are calculating for the occupied cell. So here the occupied cells are, so right, the occupied cell. So where there is allocation, means here this is allocation, so this is occupied cell. Where there is allocation, these cells are occupied cell. I will write first occupied cell, and relation is u1. I will use another color, just so here u1 v1, that is occupied cell. So here u1 v1, at this location there is a occupation, 30 is a occupied cell. Now here u2 v1, that is occupied cell. Again I will write u2 v2, sorry, u2 v1, as well as u2 v2, then u2 v3 is also there, then next is u3, then next is u3 v3 and u3 v4. So these are the occupied cells. Okay, so these are the occupied cells. I will zoom out this, then you can, that will be visible. So here we have written the this is occupied cell. Now we know the relation of this occupied cell is ui plus vj is equal to cij. So this is a relation. So ui means this row. So here we can write u1 plus vj means here v is a v1. So u1 plus v1 is equal to cij. Cij is nothing but this cost. 6 is a cost. So u1 plus v1 is equal to 6. Similarly, this for another occupied cell. This is another occupied cell. u2 plus v1. I will write u2 plus v1 is equal to cost is here 5. Then similarly for third, u2 plus v2 is equal to cost is 11. Similarly u2 plus v3, that cost is a 9, and here remaining 7 and 13. So u3 plus v3, right, u3 plus v3 is equal to 7, and u3 plus v4 is equal to 13. So these are the cost. So if you check once again, so these are for all for the occupied cells, and these are the cost 6, 5, 11, 9, 7 and 13. These are the cost. So please take the cost here 7, 13. Don't take this allocation. Sometime you may take this allocation here and all the calculation may go wrong. So look carefully here, you have to take the cost here. So this is a relation, and this we have written the equations. Now we have to solve the equation. For that you can assume any value u1, u2, u3, u4, any value equal to 0. So initially I am assuming that, assume u1 is equal to 0. So first step, suppose I am assuming u1 is equal to 0. When I am assuming this u1 is equal to 0, so this equation becomes 0 plus v1 is equal to 6. Now if you solve this, you will get v1 is equal to 6. Now you will get the column number 1. v1 is nothing but the column number 1, and you will get the value of this is a 6. Similarly u2 plus v1. Now here relation is u2 plus v1. We don't know u2 plus, but v1 we have calculated here v1. So u2 plus v1 is 6 is equal to 5, and if you solve this, you will get u2 is equal to minus 1. Okay, so here now you will get the u2 is equal to u2 is equal to minus 1. So here you will get minus 1. Similarly, now here u2 plus v2. Now we know here u2 we have calculated minus 1. So minus 1 plus v2 is equal to 11. So from solving this, you will get v2 is equal to, now this going toward other side, it will become plus. So that is a 12. So now here you got the v2 is equal to 12. Similarly, by the similar way, you have to put the remaining in this equation, and you have to calculate the values here. So I will directly give you the value, other value. So v3, so from this equation you will get the v3, and v3 value you will get a 10. Then in the next equation here u3 plus v3, so here you will get the value of u3, that is a minus 3. And last one u4 value, so v4 value you will get a 16, and initially we have assumed u1 is equal to 0. So you get all the values by solving this equation. So try solving this equation and get this value. Once we get this value, we have to solve for the unoccupied cell. So in the next table I will write once again all these values in the next table, and then we will solve further. So this is our table, and here we know that u1, initially we have assumed u1 is equal to 0. Then we know that u2 is equal to minus 1. Then u3 is equal to minus 3. Similarly v1, that is we have solved, is 6. Then v2, that is 12. Then v3, that is 10, and v4, that is 16. So these are the values. Now once we have solved for occupied cell, now we are solving for unoccupied cells. Unoccupied cells. So which are the unoccupied cell? So I will write first here occupied cells. So here there are 30 allocation. I will use another color. Then so these are the occupied cell. Here 30 is allocation, here 5 is allocation, in the 11 28 is allocation, in the 9 7 is allocation, again here 25, and here 25. So these are the allocations here we know. Now the remaining this 5 8 5, this 7 8 9, so these are the unoccupied cell. So now we are solving for an unoccupied cell, and for unoccupied cell there is a relation Cij minus ui minus vj. We know that Cij is cost, u for row and v for a column. So Cij minus ui minus vj, that is a relation. So here once again I will write the which are the unoccupied cells. So here in this case unoccupied cell is this u1 v2 is an occupied cell, then u1 v3 is an occupied cell, u1 v4 this is also unoccupied cell. So I will write u1 v2, then u1 v3, then u1 v4, then another is here u2 v4, this 7. So u2 v4 is also unoccupied cell. Similarly u3 v1, and last one is a u3 v2. So u3 v2. So these are the unoccupied cells, so where there is a no allocation. Now we are solving for an unoccupied cell, and we know that relation for this unoccupied cell is Cij minus ui minus vj. Cij means here now we are solving for this, suppose u1 v2 means for this location, so here Cij is 5, cost is a 5. So here I will write, so here 5 is a cost minus ui means value of this row u1, here 0, minus vj means value of this column, now here it is a 12. So 5 minus 0 minus 12, so if you solve you will get the value of here minus 7. Okay, so similarly you can solve for a u1 v3. So u1 v3, this location, now cost is 8 minus 0 minus 10. So if you solve this you will get a cost minus 2. Similarly u1 v4, if you solve for u1 v4, now here cost is a 5 minus 0 minus 16, so you will get a minus 11. Now for next u2 v4, if you solve this u2 v4, so here u2 v4 is 7. Now cost is a 7 minus, here it will get for 7 minus u2 value is minus 1 and v4 is 16. So here in bracket I will write a minus 1 and minus 16. So if you solve this, so you will get, now this is become minus 1 is plus 7 plus 8 minus 16, so it will get a minus 8. And similarly for u3 v1, so here 8 minus minus 3 and minus 6, so here you will get the 5. Similarly u3 v2, 9 minus minus 3 and minus 12, so you will get the first here 0. So this is improvement index, we can say these values are improvement index values. Now our final answer is, when all the values in improvement index, when all value in improvement index are positive, then we have reached to the optimum solution, means we have having answer of 1076, that is a final answer if all the values are positive. But if any value is a negative, then we have a chance to again reduce the cost. But in this case you will get a minus 7, minus 2, minus 11, minus 8, these are the negative value. Then which value we have to select? So select the maximum negative value. So here we are selecting this highest, so minus 11, so that is negative value, means u1 v4 at this location, u1 v4. So here if you check, so u1 v4 means this location, at this location you are, there may be the chance to add the allocation. So here we are having a chance to add the allocation. Now if we add the allocation at this location, now we have to reduce any one location from remaining allocation. So 25, 25, 7, 28, 5, 30, from these, all these, one must be gone, and that may come at the location of this plus sign, or we have calculated that u1 v4 at this location, here there must be the allocation. So for that we have to create a loop. So I am creating a loop here, and then I will put in the next table. So here creating loop means starting from this point and end with the this point, but we have to create loop like this. At each corner there is allocation, so here stepping stone method we can use. So here there is a allocation, here it is allocation, here it is allocation. So this type of loop we can create. So we have added this plus sign here, we have to add the allocation here. Now at this location we will give the negative sign, here we will give the plus sign, here we will give the negative sign, here we will give the plus sign, and here it will be negative sign. So why at this 28 we have not given the sign? Because there is no angle change. Where there is angle change, that in that point there must be the allocation, and we have to give the alternate plus minus sign. So here given the plus sign, then minus, then plus, then here minus, then here plus, then here minus. The next step is select the smallest value where there is a negative sign. So here it is a negative sign where value is 25, here negative, value is 7, here negative, value is 30. So we are selecting the minimum value, so 7 is a minimum value. Now we are adding this 7 value where there is a plus sign, and we are subtracting this 7 value where there is a negative sign. So I will write here, solve here. So here we are adding 7, here 30 minus 7, here 5 plus 7, here 7 minus 7, here 25 plus 7, here 25 minus 7. And now again we have to repeat this matrix here with this addition and subtraction. So I will write the next matrix here. So here 30 minus 7, so here that value may be, I will write the direct allocation here. So here it may be the 23, then here it will become a 12, then here at 11 there is a no sign change with that 28, at 9 here that allocation is going, and at this location 7 is coming. Now at this 7, 25 plus 7, 32, again here 25 minus 7, that is a 18. So these are the allocation after solving this. So here if you solve this, you will get this type of allocation. At 28 there is a no addition subtraction, so 28 remains as it is. So now these are the allocations after solving or creating the loop. Now once again you have to calculate the initial basic feasible solution for this. So here you will get 6 into 23 plus 5 into 7 plus 5 into 12 plus 11 into 28 plus 7 into 32 plus 13 into 18. If you solve this, you will get the answer 999. So here we can see initial basic feasible second solution, because we have solved for a first. So this is a 1076, that is a cost, total cost. But by the Modi method we have solved this problem, and we reach that this 999 is the cost. So that is a reduced from 1076. Now for it, in this problem it is asked for a first one iteration, only one iteration. So we will stop here, but further you have to again check for there is any reduction in the cost. So for that again you have to put this here u1, u2, u3, here v1, v2, v3 and v4. Again we have to calculate for the occupied cells, this is all occupied cell, then again calculate for unoccupied cell, then check for improvement index. If again improvement index is negative, then again you have to solve, repeat the procedure until and unless all the values in improvement index are positive. You have to solve this problem, and that will be reducing the cost. So this is initial basic feasible solution 999. So that is our final answer, because in this problem it is asked for one iteration only. Okay, thank you.